All right. So from 5-4, what questions? Anything from 5-4. Measure of angles. There are problems just like this on the test. I just sent your test to the copy center yesterday. Finding the value of x. What's up? It's at my house, actually. I can get it at lunch. I mean, I wasn't going to, but I can. What do you need it for? Our laptops, is it an SD card?
It's not an SD card, it's an old memory stick.
I wonder if Robert would have a converter, because he's got a few different card converters. Yeah, check with him, and then I can get it if we need. Or I can get it between school and staff meeting. I can just run real quick. Nothing from 5-4. Going once. Twice. Getting closed. I'm too afraid to hit buttons that I don't want to hit. 5-5. Caleb, thank you, sir.
Question 17. Otherwise, using.
A woman is plotting out a garden bed, sounds like my mom. She measures the diagonals of the bed and finds that one is 22 feet and the other is 23 feet. Could the garden bed be a rectangle?
Wait, never mind, this just made it. Yeah. I have no clue. I didn't understand that.
Careful reading
Alright.
is probably why. Other questions? Going once? Twice? Happy birthday.
We love you, David.
5-6. Questions about trapezoids and kites. Kites have perpendicular diagonals. One of them gets bisected. They have two angles that are congruent. Yes, because I have a guest teacher and I do not want them to teach. But thanks to Haley Blanchard, if any of you guys still know her, she gave me a suggested sub that has been subbing at Thomas in math a bunch, and he's actually a math guy. So if I can get him as a preferred sub and get him in here, maybe he can actually teach you guys. That'd be sweet. Yay! Yay! Nothing from 5-6. Going once. Trapezoid mid-segment theorem is the average of the bases. You know that your base angles in an isosceles trapezoid have to be congruent with each other. The mid-segment bisects the sides. These angles would be congruent. There's congruent right triangles. There's all sorts of ways that we can prove that. Going twice. Closed. 5-7. Ooh, coordinate geometry. I'm not surprised because this was the day that I wasn't here. I'll just cycle around the room. Michelle. 6. So somebody asked Mr. Hall about this, and we were discussing it. If we were going to talk about placing a kite in the coordinate plane, this is just asking you, like, what would be the best way to do this? And I don't know if there's any preface. So what are the coordinates of the vertices in each figure? So if you were to place this on the coordinate plane, what do you think your strategy would be for making this easy? Megan? Yeah, put all the points on your axes. Now there's also another really easy thing I can do. I can just make the axes be the diagonals, which can happen as long as I put my points equidistant out, because I know that this diagonal gets bisected, and then my other diagonal does not get bisected, so this is actually longer to make it down here. So if I make my kite, I want to draw it first, then I can assign some values. That's not a nice kite. I'm sorry.
Yeah, it is.
So we know that this length is equal to this length. That length is equal to that length. We know that these are right. Well, these are the axes, so we know that they're right angles. But really, Does the distance up that this point is relate to the distance down that this point is? No. Or at least not necessarily, right? It could, but not necessarily. So if I make this some value of A, what should I make this? Yeah, something that doesn't have A. So let's go B. Then what would you think about my side points, my left and right points? C and negative C. And of course we could assign the Y values or the X values that are zeros there. But this would just be 0A. This would be C0. That would be negative C0. And that would be 0B. So it was a very open question, which sometimes those are the hardest for you, like critical thinkers. You want more directions. You want like specific details. It's just very open-ended. Yeah.
I think my biggest confusion is that it says the coordinate plane, so it makes me think that there's a coordinate plane that got cut off, not a coordinate plane.
Yeah, I was kind of confused about that. I was like, is there...
Oh. So, yeah, I understand your confusion. You were thinking there'd be a graph showing, or like X, Y. Yeah. Yeah, it should have probably said a coordinate plane if we wanted to be grammatically correct.
Yeah, I thought it was like...
Yeah, the would be
cut off,
referring
so
to
it wasn't
something.
quite all of the questions.
No, that's... And you guys can always text me those questions. Like, you guys have my cell number, right? Well, okay. But you could... There's other messaging services. You can message me on Schoology. You can email me. There's many ways to get a hold of me. Schoology also push notifies me. So that's actually better than email. So if you Schoology message me, it push notifies to my phone. Emma. Yeah. Or, if it was just B, B is a negative value. And because we don't have B used anywhere else, I could leave that as just B, and I would just have to say B is a negative value, or I could make it negative B, and then B is a positive value. So it depends on, like, it's right either way. Other questions from this one? Sorry, I said I'd go around the room. Caleb.
I had a question on 12C.
All of 12? Probably can. Draw an isosceles trapezoid with height 2h, bases 2a, 2b. Let me zoom in a bit. So that, okay, so midpoint of the base with length b, so that the origin is the midpoint. Okay, so first thing we do is we see that they're referencing the origin, so I need a coordinate plane to make a coordinate plane. Then I know that my base is 2a and 2b, and the origin has to be the midpoint of the base with length 2b. So for this base to have length of 2b, what would be the coordinates of these points? Emma? B and negative b. So this would be b0. And actually I should shift that down since we're going to be going up. And this would be negative b0, which makes the length 2b. Or not 2b. Aha. So then I need a base that is 2a. So that's going to be somewhere up here. But how do I know how far up that is? Caleb? It's up 2h. So that point, not that we really need it, but it's 0, 2h, which means that if I come out here to my points that are actually my base, what would those locations be? Megan? A, 2h, and negative a, 2h. I'm not yours. I'm finishing. That's all that it wanted me to do. So give the coordinates of the vertices of the trapezoid. We did that. Compute the lengths of the legs of the trapezoid. So these guys, we need to compute that length. Ethan? And really, the distance formula is a manipulation of the Pythagorean, so you're right either way. So I need to figure out how long this is And I'm just going to draw straight through my stuff. And then how long this is. Now I know the height. That's 2h. But this distance. Yeah, what do you think? Remember, we're talking distance here. Ooh, careful. You're really close, Calvin.
B minus A.
B minus A. Now, why don't we use negative B?
Because that's like where it is on the graph.
Yeah. That's where it is, not distance. The length of this is B. Take away, if you want just this, take away the A. So that length will be B minus A. And then, like we said, we can apply either for distance. And we know that those distances will be the same. So we can apply the distance formula, which is just the radical of the delta x squared plus the delta y squared. And the delta means change. So my change in x, we just said, is b minus a squared. My change in y, we said, is 2h then squared. Ooh, what happens when I have b minus a squared? How do I square a binomial? Calvin?
B squared minus A squared.
Ooh, close, but not. Binomial squaring has a special process. This is going to end up optimal, but that's fine. Megan? Foil! Anyone ever heard of foil? Not aluminum, not tin. First, outside, inside, last. Now wait, what? We only have, What's it mean to square something?
Itself.
Times itself. So this is really b minus a times b minus a. So we take the firsts, b times b, and we get b squared. We take the outers, b times negative a, negative ba. We take the inners, negative a times b, negative ba. We take the outers, the last, negative a times negative a gives me positive a squared. I combine my like terms, and I have the negative 2ba, and this really ends up being b squared minus 2ba plus a squared. So I'm going to keep, this is not for D, I'm going to just keep working vertically. So D then becomes the square root of b squared minus 2ba plus a squared plus 2h squared. Rhea?
Well, actually, I have a question.
Okay.
Why are you doing B squared minus B minus B? Why did you say minus B once?
Because we did the outers. So we have to multiply, like, if you think about distributing this multiplication, this FOIL process really comes from the fact that B needs to multiply by the B and by the negative A. Negative A needs to multiply by the B and the negative A. So really, firsts, outsides, insides, lasts. That's where FOIL came from, is an extension of the distributive property. So that's why my insides and my outsides multiply to get the same thing. So I'm always going to have a repeated term, and I'm going to end up with minus 2b, minus 2 whatever that repeated term is. Yeah, or plus 2.
What was the point of FOIL? How does it help? Because you still have like a bunch of variables.
Because this is a binomial that I can't combine. So I can't square it if I can't combine it unless I use a process like
And you
this.
still can't combine the bottom ones either.
You're right, but at least I've squared it. And now I can put it into my square roots and work with it. So hang on for a second, because I'm not done. You're acting like I have finished, and you're still confused. I've not finished. Do you understand how we at least get that value? Not why we did it, but how we got it. Okay. So then, this is plus the, well, what's 2h squared? What happens when I have a variable term with a coefficient squared? Ethan? Yeah, you square both. You square the 2, square the 4h squared. And that's still under the radical. Now, what am I able to do? Can I get rid of those parentheses? Like, are they doing anything? Not really, right? That's our distance. Really, really, really messy. But if then we got told what B was, what H was, and what A was, we'd plug all those values in and we would know our distance. But this is in the form of any isosceles trapezoid. So you now have a formula. This we could name our isosceles trapezoid distance formula of the leg. But we don't need to. It's all about how do we problem solve to get there. So it's not that it's going to clean up into something nice and pretty, because we don't actually have numerical values. We only have variable values. And only having variable values makes things end up still kind of messy. I really don't think so. I forget, like, I don't want to guarantee no, but there is coordinate geometry, but I don't think I asked you to do the distance, because we haven't done a lot with distance yet. Does the finding the distance make sense? It's the coordinates. So just drawing it out and showing the coordinates is fine for B. Do we need to do the slopes or the midpoints?
Wait,
That was just C.
Wait, that was C?
That was part C. Compute the lengths of... Guys, I told you, this was not D. I'm just using this space. I needed space to... Guys, I said this.
Yes.
Open your ears and listen. If you don't believe me, go back and watch the video. Haha.
I'll do that. I'm just kidding.
So your slope would just be delta y over delta x, which would be your 2h over your b minus a.
Yes.
And your midpoints would just... You calculate it out like we have already done.
Wait, so slope would be wait.
Change in y over change in x. Rise over run.
So it'd be
Yeah, and then the opposite slope for... Well, no. You'd want to calculate it again. Because it's not perpendicular. Yeah, be careful with that. So, I'm not drawing the trapezoid again. But if I look at my left green triangle up there, my change in y, where's m equals delta y over delta x, my change in y was 2h. My change in x was b minus a. I can't combine any of this. That's my slope. Now, if I know then my h, b, and a, I know my slope immediately. But all I need to know is what are the values of those coordinates. I'm not capturing this because in case we still have more questions, I want to keep the trapezoid up there.
I was had the question.
You have the midpoints. So, it's really half of each of these distances, but it's not half of the base length. It's half of the length that the sloped line covers. So what is the change in x of that sloped line? How far does that run horizontally? B minus a, right? So if we need to find the midpoint would be cover half that distance and half the vertical distance. So I know that the y coordinate for the midpoint is going to be h. That should be fairly straightforward to find. It's the x coordinate that would be the b. Sorry, since we want the coordinate, it was at negative b. Then it's going to add how much to get. So if we go all the way to negative b and then come back to the midpoint, how much would that have to add to it? Half, not of a.
Or no. Half of b minus 1/2.
Or you could just say b minus a over 2.
Yeah.
So if we went the distance of, actually we could start by going the distance of a and then add, or go the distance of b and then subtract. Do you get what I'm saying? if we only go A, then we add the half B minus A, like B minus A over 2. And if we go the negative B, then I have to come back. So I'd rather go a negative A and then, which actually adding, since we're going the negative direction, will be subtracting. So minus B minus A over 2. Because that's half of that other distance. So I might need to pull this back down here. If we do the positive one, I think it'll make more sense since it's not so minusy and stuff. Let's pull this down for a second. I'm going to clone this page. So, if you think about the midpoint on the positive side, because then we can just make the other midpoint the negative, right? So we're thinking about this point right here. We know its height is going to be h. It's finding the x that's the more difficult part. So we know that this distance right here is a. We've already been told that. So we go a. Then I need to say, well, how much distance is covered here to go half of this green distance? And we figured out that green distance is the distance of B minus this little chunk of distance is all of B, but actually take away the A. So it's B minus A, which is what we had said on the other side. So that X distance right here, this, it's very hard to do this, this little distance is half of the B minus A. So that is B minus A over 2. Just that. That's not the X coordinate. That's this tiny distance. Are we cool with how I got that? So then, to know where this midpoint is, well, it goes the B minus A over 2 after it goes the A. So it's really A plus B minus A over 2. Because I go the distance A, then I go the little distance of B minus A over 2. Yeah?
Also, B minus A was equal to C and AC instead of that in the coordinates just because it makes sense for that.
Sure. Yeah, if you want to do that. She introduced a new variable. So then, I can, this can be B over 2 minus A over 2, right? I can split up my fraction.
Could you just use the midpoint formula where you average the X values?
I mean, yeah. But if we write this out and if we do this out, we're going to get the same thing. So yes, you can.
It just seems simple.
Sure. I mean, and that's all like whatever your preference is. So if I solve this out, this really, when I combine it with my A, adds in, or takes away, really, subtracts half of the A away. So really what I end up getting is half of A plus half of B. But again, the reason I take the longer route sometimes is if you don't remember the formula, how do you solve the problem? It's not about memorizing formulas, it's about problem solving. So if you have the formula in your memory, sweet. But if you don't, you gotta still be able to solve it. Does that make sense? Why, because I know sometimes you're like, why is he taking such a roundabout method? Well, I don't like saying, let's apply this formula that we have memorized. No, well, not everyone's going to have it memorized. So it's all thinking about what do we know, what can we do? Do we still have questions on this? Because we can do it another way.
Other midpoint would just be
The opposite.
like it would be
Literally. So you could make it negative A over 2 minus B over 2. All right, are we cool here now? Yes. 13. How long do I even have you guys? 38. Sweet.
I have a question.
Yeah.
Regarding the history, will we have like a practice test or anything?
Yeah, we're gonna do a review game on Wednesday, where essentially we like work through a practice test. Yeah, they asked for that yesterday. So I am at your whatever you want to say. And actually, if you guys want to know what it's gonna be, I forget which one I sent. Here. Are you sure? Because I'll come back to that. Because I feel concern. I hear concern. So hold on. My computer's just way too slow. We could talk about question 13 while it's loading. How can you tell without using the... So, I forget which form of the test you guys will be taking. This might be the actual test that you'll be taking. But here's what you're going to be asked to do. Find values of variables when you know it's a parallelogram. So you know congruent statements. Find the variable values when you know how many sides the polygon has and you can total up the angle measures and figure it out based off that. Here, you can look at this as like the parallel lines, or you can look at it as the right triangle. That's kind of a huge hint. Classify the figures precisely. Find the coordinates. This is your coordinate geometry work. Determine true or false. If false, provide a counterexample. If true, explain why. More coordinate geometry, finding the midpoint there. And explain ways rectangle is similar and different from a kite. Not too bad. No crazy proof questions. None of that. So, that's what you can expect. Would you like to go over 13, or are you good, Michelle?
No, I can use it for 12 currencies and coordinate geometry.
Okay. So, are we good to move on to 5-8, or are there more 5s? Okay, 5-7?
Yeah, I have one question.
Okay.
Number 7.
Rhombus QRST is centered at the origin. QS equals 4R, and RT is 4T. So if it's centered at the origin and it's a rhombus, that means what is the origin? If it's centered at the origin, what does it mean? Carmen?
Origin, like the point in the middle of the rhombus.
Yeah, so like that point where the diagonals cross, right?
Oh, good, I did that right.
Yeah.
Oh my goodness.
So RT is 4T. I'm going to capture this so we have our info. And then I'm probably going to scooch it so I have some space to draw. Actually, I wonder if I can cut that out. I probably can't. I'm just going to zoom way in so I have room to work. Okay. So, first thing we do, draw your coordinate, x, y. And then we know origin QS is 4R, and that's one of the diagonals. RT is 4T, that's one of the other diagonals. So really, we just need to draw the rhombus and then assign everything. So I don't know, you could do something like this. No, I'm probably going to have to shift
Can
it.
you just make like a vertical one and put...
Well, so then it becomes a square.
No, like with the vertices on the axis.
Yeah, that's what I did.
Oh, I see what you like. Here, here, there, and there.
Yeah, that's what I did.
It's just hard to look good because my art skills suck.
Well,
I feel you.
That's what labeling is for.
That's fine. And just
And now it's perfect.
So then we have to label QRST. Then we are told QS is 4R. And since we know this bisects, we know that this is 2R. And this is 2R. So then I know what the coordinates are going to turn into. If RT is 4T, then this is 2T, and this is 2T. So my coordinates just become like a negative 2T, 0, positive 2T, 0, Positive 2r, 0, no, 0 2r, and 0, negative 2r. Thank you for reminding me of how to make that much easier. If you are able to put all coordinates on the axes, that is the best option. So I was just, see, that's the funny thing. Sometimes because you guys are practicing this currently, I'm kind of out of practice. I know all this stuff, right? It's back in the brain, but I'm out of practice. So I love it when you guys are like, wait, there's an easier method. Like, that's great. Now, really, I mean, that could have looked a lot of different ways. You could have had your points wider on the right and then closer on the verticals. It's not a big deal of how it looks. It's just how you label. Yeah. Any other 5.7? Carmen?
What does, it's like a really small question. So, it's question 5B, and it's, write the given and prove statements. I'm not quite sure what that means. I think it's just the wording.
Name the coordinates of A, B, C, D. Calvin. You already have your hand up. I got to read this still. So go ahead if you know what's up.
In a two-column proof, the first statement is the given statement, and the last one is the prove statement, like what you're trying to prove. Oh, okay, just kidding. Thank
So
you.
it's super easy.
Yeah, plan a coordinate proof to show that the parallelogram is a rectangle. So the prove is prove that that ABCD is a rectangle.
Oh, and then you're given.
The given would be ABCD is a parallelogram, base B,
Okay.
height H.
I just didn't know exactly what I was.
Yeah, which you can even make more specific and say DC is congruent to AB is congruent or equal to B, AD congruent to BC equal to H. Then you go from there. And then what information do you need to prove that the parallelogram is a rectangle? The what? Angles need to be right angles. Wrong angles. All right, 5-8. We got 5 minutes. What's up? Numero 10. If the diagonals of a quadrilateral are perpendicular, but do not bisect each other, then the quadrilateral is a kite. How will you place the quadrilateral in the coordinate plane? What formula will you use, and what are the coordinates of the vertices? Oh, okay, so we're talking about a kite, and the diagonals being perpendicular, but not bisecting each other. We actually already drew this today. But I forget if we were trying to draw it as a kite, or if we were actually trying to draw it as something else.
On 7, number 6, place a kite in the coordinate plane. Is that the one you're talking about?
Yeah. So, here, 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 here. These are congruent. These are not. These are congruent.
It's actually spelled like axes.
Yeah, like A-X-E-S. It's one of those weird plural words. Goose, geese. So,
What?
goose and geese. The
Oh,
O.
I
it
thought you
cha-
said goosies.
No, goose and geese, mice. Well,
Mice
mice
and
don't
geese.
work. Mouse and mice.
I like my
Meese.
You
Mouse.
know
Um,
I have my.
So we did this already, but the big thing that you'd want to do is make these easy values. So like a negative A and a positive A for your x coordinates, maybe a B for your vertical and a negative C or something for your other vertical. Huh? Because these are not congruent. They're not the same distance from the origin.
Lest it be around us.
Yeah, because then it reclassifies as the next more specific name. Anything else? Yeah, Michelle. 11. The vertex, use coordinate geometry to prove each statement. The vertex of an isosceles triangle is on the perpendicular bisector of the base. Oh, so isosceles triangle, right? So we've got this equal to that. Perpendicular bisector would have to show that it is in the middle. So if we had x, oh, come on, close. And this is not straight across, but close. So if it's an isosceles triangle, we can prove things like if it has a height of h, then let's just say that this has a distance of a, and this is negative a. So then this has to be the center. So we know it is the bisector. And then since it is an altitude, and this is an isosceles, we can then show that since this is 0, 0, and this is 0, h, since the slope is undefined, it shows that it is vertical. The base has a slope of 0, we could prove by change in y over change in x, and therefore this is a right angle, and we're done. That's it. You just have to show why we know it's perpendicular. Well, you compare the slopes when you have inverse slopes, well, especially when one's undefined and one's 0, those you know they're your vertical and horizontal. Brian?
Why is it called undefined?
Because you can't find the slope because it's infinite. Because your change in y is infinite over a 0 change in x. So actually, the slope of this line, which is absolutely impossible to do. You can't use infinity, and you can't divide by 0. So it's like nonsense. But it's like you can't say it, you can't give it a name, because as soon as you tip off undefined, you have a slope. So it's just that as soon as we get there, we can't define it, but we know what it is, we just can't define it. There's no way to talk about it numerically, which is one of those interesting situations. Like, math can't explain that, because it can't be done. What's up, Calvin?
Number 10, what formulas will you use? I don't get that because it's not telling us to do something.
That's more asking about like the trapezoid. I hate that they use the word formulas. It's really more like the theorems of knowing that the you bisect the one and you don't bisect the other. And really the formulas we use would be your slope formulas. So knowing that the if you recognize that n is slope, delta y over delta x, and then you would show applying the change in y being h, or whatever we made it, and the change in x being 0, that's undefined. The change in y across would have been 0 over the change in x would have been 2a. That becomes a slope of 0. Then you can compare and show that they are perpendicular.
That was the other question.
Yeah. What?
For 10, it's not telling you to accomplish something, so I don't get how you pick formulas to use.
Hold on. If the diagonal quadrilateral perpendicular do not bisect the quadrilateral kite, so that's really a dumb question. I don't know why they even asked that. It's just applying the fact that you know that if this coordinate is this far away from the center point, or what we use as the origin, then the other one has to be congruent. And if this point, like, I don't like that question. Don't worry about that one.
Okay.
Yeah, that's a poor question. I got to get you guys out of here. We're out of time. Oh, actually, I have 3 minutes. I forgot. We actually get more time today. Are there any other questions? Or we have 1 minute if you're going off computer time. Michelle?
Number 4.
Show that you can reach each type of conclusion below using coordinate methods. Anyone figure out number 4? Are you able to use coordinate methods to prove congruent angles?
Because you can prove angles is 90 degrees using slope, so you can prove angles.
Yeah, so a manipulation of slope formulas can compare the slope of one line to another, and then look at a different 2 lines, compare their slopes, and we could prove the angles to be congruent. Easiest thing to do would be perpendicular, but we could do it with any set of lines. It just gets messy.
Well, number 7, are they the same thing then? Or no, it's equilateral.
It says equiangular, but yeah. So you would have to do the slopes for all of them and compare each slope, like here to here to here, all those slope comparisons.
Or you could find sidelines.
Yeah, but well, yeah, because the trig.
Oh, that's true. Okay.
Because you can always drop in altitude.
Well, I meant if you have an equilateral triangle.
It has to be equiangular, yeah. So, as Calvin's saying, if it's equilateral, it has to be equiangular. So if you don't want to solve the angles, just solve the distances, prove it's equilateral, then you know it's equiangular. On Monday, we will start Chapter 6, as I've sent out in the update email that goes home to your parents. And then Wednesday, we will play review game. Thursday, you will be taking the mastery. Thank you guys very much. Have a wonderful weekend. Huh? No new homework. No, I mean, if you're done with all your Chapter 5, you're good. Thank you, guys.